Hey guys, welcome to our presentation of Drifting Continents, Section 3 in Chapter 1 of your book. We're going to be covering a lot of stuff today. There's going to be a lot of notes to take, and definitely listen and pay attention to the video as we go along. If you need to stop it to go ahead and copy down more notes, please feel free. You can always rewind a little bit, listen to another section. Make sure you take your time. This is just as if we were having a lecture in class. Alright guys, let's go ahead and get started. Ever since Columbus came to the New World and people started being able to see maps that had both Africa and Europe and North and South America, people noticed that in some ways it looked like they should fit together like the pieces of a puzzle. You guys probably noticed this earlier when you were doing Question of the Day. However, they also assumed that at that point, all the continents probably had been in the same place that they had always been. However, there was one scientist in the early 1900s who started to think a little bit differently. His name was Alfred Wegener. He's a German scientist, and he started noticing not only the shape of the continents, but he started gathering some other evidence as well. Let's talk about the conclusions he came to. After examining a lot of the evidence that he found, Alfred Wegener came to a hypothesis. His hypothesis was that all the continents were once joined together in a single landmass and have since drifted apart somehow. Wegener's idea that the continents slowly moved over Earth's surface has come to be known as continental drift. According to Wegener, the continents drifted together and at one point formed a supercontinent called Pangaea. The word Pangaea in Latin means all lands. The sea at this time was actually called Panthalassa, which means all sea. According to Wegener, Pangaea existed about 300 million years ago, and that would have been when reptiles and winged insects first appeared, when we still had dinosaurs. Tropical forests also covered large parts of the Earth's surface. He explained that over tens of millions of years, Pangaea began to break apart, and the pieces of Pangaea slowly moved to their present-day location. As with any hypothesis in science, once you've got it, to make it a theory, to make it acceptable, you're going to need evidence to back it up. Let's take a look at what Wegener used. Wegener gathered evidence from different scientific fields to support his ideas about continental drift. He studied land features, fossils, and evidence of climate change. For land features, he looked at the locations of mountains on different continents and how some of them seemed to match up. The fossils were probably some of the biggest evidence that he found. He found fossils in far-reaching places of animals and plants that couldn't have crossed the oceans, but the same fossil on different continents, and we'll look at that more in a second. Remember, a fossil is any trace of an ancient organism that has been preserved in rock. He also looked at evidence of climate. In areas that are now very, very warm, we see marks from glaciers where at one time obviously it was very, very cold. In other places in Antarctica, we see fossils of organisms that had to have lived in a much warmer climate. So looking at evidence from climate change, he also used that. Let's take a look at some of the evidence around the world that he used. On this map, which is also in your textbook on pages 20 and 21, you can see some of the areas. On the key here, you can see that the red areas in South America and Africa already, which looked like they line up and kind of fit together like puzzle pieces, there's the same type of mountains in both of those areas. Again, that would be one of those land features that he used. When he's looking at fossils, he's going to be looking at that Glossopteris, Lystrosaurus, and Mesosaurus fossils. And again, if you look, you can see the green of Glossopteris starting in South America, and a band across Africa, all down in Antarctica, and even over in Australia. And again, there's no way really that we know of for that plant to have traveled all the way across the ocean. The seeds would not have survived. So Wegener hypothesized that at one point those continents were connected, or at least much, much closer together. Again, the third piece of evidence he used was evidence from climate. And here's where we can kind of look at the coal bed deposits and the glacial deposits. And again, you see coal beds in different areas all the way across. And those were just areas that at one point were probably much closer together. We get coal beds from having large forests that have died and become buried and over time have turned into coal. You can also see glacial deposits in the light blue. We see them all across Antarctica, which we might expect, but we also see them in Australia, and right smack dab in the middle of Africa, which we would not expect, assuming that the climate is the same. with all that evidence from land features, fossils, and climate, Wegener put all of that together and started to sort of fit the continents together and see what might they have looked like at one time. What was his theory? If they weren't always in their present locations, where were they? Well, again, if you look on page 20 in your book, you'll see his hypothesis of what he believes Pangaea probably looked like, and we'll take a look at it here on this next slide. Here we can see with all his evidence what Wegener hypothesized Pangaea probably looked like. We can see the folded mountains in South America and Africa lining up, and those bands of fossils that he saw, again, South America, Africa, India, Antarctica, and Australia. We make that band where those were probably connected. The big evidence in North America and Eurasia is going to be that line of coal beds, which again speaks to a once ancient forest being in that location, and those being much closer to the equator in a much warmer, more temperate environment than they're found in now. So this was his hypothesis. Let's talk about his eventual theory that was actually published.